In this lesson, we're going to focus on some more pieces of coordinate geometry, and we're going to review how to graph lines in the coordinate plane, and we're going to talk about parallel and perpendicular lines as well. So let's just do a quick review. When we talk about slope, we're talking about the change in y over the change in x. That's how we define what slope means. So if you look here, this little triangle here, that's a delta. You may recall from science class. That means change. So slope is the change in y over the change in x. And so when we look at how fast y changes compared to how fast x changes, that gives us a measure of the steepness of any line. So here you can see we have an example of a line, and that line happens to have 2 points on it. Those 2 points are given by coordinates. For example, this one has the coordinate x1, y1. This one has the coordinate x2, y2. And the formula that we use for slope is y2 minus y1 divided by x2 minus x1. This is not a formula you need to memorize. It's given to you on your Ames reference sheet. You just have to know how to use it. So when you subtract the y values, what you're doing is finding how much y has changed. You're finding that vertical distance. And when you subtract the x values, you're finding out how much your x values have changed. I started here, I ended here. This is how much x and y have changed. Then you're comparing those two changes in a ratio. For example, you can see in this picture, my y values have changed. They have increased by 4. And my x values have also changed. 1, 2, 3, 4, 5, 6. They have changed by 6. So if we look at a ratio of the changes in y, which was 4, divided by the change in the x values, which was 6, we get the slope. And we can reduce this fraction. So this particular line has a slope of 2/3. Alright, so that was a quick review of slope. Let's find the slope between 2 points. It really helps to label your points x1, y1 and x2, y2. Especially if you're not doing it graphically and you're just looking at using the formula. So if I was going to plug in these points, I'd plug in 6 for y2 minus -8 for y1, and then I would divide that by -2 for x2 minus 4 for my x1. Now let's simplify that. 6 minus -8 is, of course, 6 plus 8. That's 14. -2 minus 4, that's -6. So 14 over -6 is my slope, but we're going to reduce that. So 14 is divisible by 2, and 6 is divisible by 2, and we have a positive divided by a negative. So my slope here is -7/3. Okay, so we'll talk about how to use slope and graph some lines in just a second. Okay, so now let's do a quick review of how to graph a line. Remember, one of the easiest forms to work with is slope-intercept form. That's when your line is in the form of y equals mx plus b, where m represents the slope of the line and b represents the y-intercept of the line. In other words, where it crosses the y-axis. If you were to draw a quick picture, you would say this line has a slope equal to m, and you would say that this line crosses the y-axis at b, or in other words, the x-coordinate is 0 and the y-coordinate is b. So let's just practice graphing a few lines. If we wanted to graph the line y equals 3x minus 4, you can see that the y-intercept b is equal to -4, and that's where we start. So we go down 4, and we plot our first point. Then we use the slope to plot a few more points on the line. So here my slope is 3, or you can think about that as 3 over 1. Excuse me, in other words, up 3, a rise of 3, a run of 1. Up 3 over 1. I usually like to plot as many points as I can fit in the area of my graph because that helps me keep my line nice and straight. And then we just connect the dots. And I'm going to make this one blue because it's going to go with that blue equation. In the next one, we have y equals 1/2 x plus 3. So again, my y-intercept is 3. So I'd start at 1, 2, 3 on the y-axis. My slope is 1/2, so I'm going to use that to plot more points. So a rise of 1 and a run of 2. Up 1 over 2. Up 1 over 2. So we're going to continue like this. And then again, graphing as many points as you can so you get a nice straight line on your graph, and it's very, very accurate. This one's a little bit off, so we'll put it there and we'll make it red. You should probably use a ruler or a straight edge when plotting your lines. The last one is y equals -2x minus 1. So my y-intercept is -1, and my slope is -2, or -2 over 1. So I'll start with my y-intercept at -1, and since my slope is -2, I'm going to go down 2 and to the right 1. Always to the right. We're either going to go up and to the right, or we're going to go down and to the right, but it's always to the right. So from here, down 2 over 1, or we could go up 2 and back 1, and that helps us get a lot more points on the line as well. So connecting the dots, here we go, using our straight edge, nice perfectly straight line, and we'll make it green to fit with the equation. Beautiful. Okay, so you can see we have these 3 different lines here, and they're all kind of intersecting in crazy different ways. But what we're going to be interested in is the relationship between lines that are parallel and perpendicular, or maybe neither of those two things, and how do we tell if that's happening. So, parallel and perpendicular lines. Let's start with the parallel ones. Parallel lines go in exactly the same direction. That means they're going to have the same steepness, and that means they're going to have the same slope. So the slope of one line will equal the slope of another line. Perpendicular lines aren't quite so easy. They have what we call opposite reciprocal slope. So opposite means one is positive and one is negative, and reciprocal means the slopes are going to be flipped from one another. So a real mathematical way of saying that is, if we have one slope, m1, the other slope will be -1 over m1. That would equal the second slope. So if we had an easier way to describe it, if we said that the first slope was a over b, the second slope would be -b over a. You see how we just flipped that upside down? Alright, so let's look at a couple examples and look at how these slopes relate to one another. What's parallel and what's perpendicular. Say hi, Calvin. Say hi to the computer.
Hi.
Say hi, everybody.
Hi, everybody.
Okay, now go eat your dinner. Alright, so let's graph these lines and see how they relate to one another. So the first one is 3/2 x plus 1. So we start at 1. And then we plot our slope of 3/2. So up 1, 2, 3, and over 2. And that gives us some more points on the line. And we can go down 3 and back 2 as well. And then we'll get our straight line tool here. We'll plot this and we'll make it blue. Alright, so there's the first one, 3/2 x plus 1. Now if I wanted to graph 3/2 x minus 2, it's going to look really similar except for my y-intercept is at -2. And again, I'm going to use 3/2 as the slope to plot more points. So up 3/2, up 3/2, etc., etc., etc. Get my straight edge tool, that's plenty of points on here. We can see that line, perfect. Let's make it red. Dun, dun, dun. And you can see these two lines right here have the same exact steepness. They're going in the same exact direction. These two are clearly parallel, and you can see that they both have a slope of 3/2 because parallel lines have the same slope. Now let's look at the last line. We have y equals -2/3 x plus 1. So again, my y-intercept is 1, but this time my slope is -2/3. So that tells me I'm going to go down 2 and over 3 to plot the next point. Down 2 and over 3. Or I could go up 2 and back 3. And now it looks like I have enough points to graph a nice straight line. And then I'm going to select it and make it green so we can tell what goes with what here. But looking at these lines, you can really see the relationship between them. They even look like they intersect at 90 degrees. So the red and the green make a 90-degree angle, and the blue and the green make a 90-degree angle because my green slope is the opposite reciprocal of the other two. Here my red line had a slope of 3/2, and my green line had a slope of negative, flip that upside down, so -2/3. So these guys have to be perpendicular. Alright, so let's just use this as an example to find some lines and some slopes that are parallel or perpendicular. So example 3, let's find the slope of a line that's parallel to y equals 2x plus 5. So here in this line, we can see that the slope is 2. So the slope of a line that would be parallel would be 2. So a parallel slope would be m equals 2. Sometimes you can use notation to talk about this, so we could do m parallel would equal 2. If I wanted to find the slope of a line that was perpendicular to this, my original slope is 2. Think about it as 2/1. So my perpendicular slope, you could write it as m, and then do a little subscript to show that it's perpendicular, would be -1/2. And it's that easy. In the second part of the notes that you'll either do at the end of class or you'll do for your homework that's due Friday, we'll talk about how to use these kind of slopes to write the equations of some new lines and lines that go through particular points. I just wanted to do a quick recap of horizontal and vertical lines. So how do you tell what's what? If you wanted to graph the equation y equals 2, the easiest way to remember what this looks like is that it crosses the y-axis. If it crosses the y-axis at 2, the only way that line can do that and cross the y-axis is if the line is actually going left to right. And this is one of those things we talked about in the Ames prep class, is that we always confuse it because we think the y-axis goes vertically, so y equals 2 should also go vertically. But it actually goes the other way. It's going to be a horizontal line because on this line, all my y values are 2 everywhere. For example, this coordinate is -7, 2. This coordinate is -3, 2. This coordinate is 5, 2. You can see everywhere the y coordinate is exactly 2. If I want to graph the other line, x equals 3, this one we want to cross the x-axis. And it's going to cross the x-axis at -3. Well, the only way it can cross that x-axis is if the line is vertical. So x equals a number is always going to be a vertical line. The x-coordinate everywhere along that line is -3. And by the way, you can also see that these two lines intersect at a 90-degree angle, so these two lines are perpendicular. I just wanted to do a quick recap because when we're working in the coordinate plane, the distance formula always pops up. We're going to use it to help us verify, for example, if a triangle is isosceles, if something is a rectangle, all of those different types of things. So you might want to have this back in your notes again. So x2 minus x1 squared plus y2 minus y1 squared, and then we take the square root of this. Remember, this is just another way of writing the Pythagorean theorem. We're just doing it in the coordinate plane. So let's do one example and find the length of a segment AB if A is at 1, negative 3, and B is at negative 4, 4. So this is like x1, y1. This is like x2, y2. So this is a review for us, but handy in this unit that we're covering. So first we take the difference in our x's. So that's negative 4 minus 1 squared. And then the difference in our y's. So that's 4 minus negative 3 squared. Don't forget that minus a negative becomes a positive. Negative 4 minus 1 is negative 5, but we're squaring that. 4 plus 3 is 7. And don't forget your square root symbol because we have to take that at the end. So negative 5 squared is positive 25. 7 squared is 49. Then we add those two together and we get 74. Now, I'm not exactly sure how big the square root of 74 is, but I know it's somewhere between 8 and 9. I know that because 8 is the square root of 64, and 9 is the square root of 81, so that means that the square root of 74 has to be somewhere in between those two, so it has a length somewhere between 8 and 9. Exactly its length would be the square root of 74. We could also approximate that with a decimal, but I'm not going to do that right now. Alright, so that's it for this first part. Make sure to have all those formulas written down so that you can use them in your practice problems. Put your questions on the left, complete your summary. Your summary should review how to graph lines, the difference between parallel and perpendicular lines, and should work with the distance formula.